In the last class, we have discussed about before last class, not last class, before last class, we have discussed about the second way of calculation of regression equations and trend values. Now, I'm going for the third way of calculating the trend values and the regression lines. Okay. Now, when you go for this arithmetic mean and when you are taking deviations from arithmetic mean, sometimes you will come across the whole figures and sometimes you'll come across fractions. When arithmetic mean is in fractions, how to take deviations from the data, from the given variables, values. Okay, for that, you have to take into account the help of assumed mean. And this assumed mean, it may be in the data given or you can take from outside, whatever it may be. So this assumed mean, after taking the assumed mean, okay, you have to take deviations from the actual values. And whatever it may be the procedure that you adopt when you go for second way of calculation of regression analysis. The same thing, the same procedure also it is followed over here. But here we have to take deviations from the assumed mean. And when you take into account the previous one, we have to take the arithmetic mean. Next, even though you take assumed mean, you must compulsory calculate the arithmetic mean of the variable values, whether it may be x or may be y. So compulsory arithmetic mean you have to take for x variable and it will be bar x, and compulsory you have to take arithmetic mean for y variable values and it will be represented by bar y. And what is the procedure and what is the formula that we have to use when we go for arithmetic mean? Now, when you go for arithmetic mean, for the third procedure, okay, we have to follow some variations and we have to go for the things. Now, regression equation of y on x, here x is independent and y is dependent. Mind it, x is independent variable and y is dependent variable. The formula is y minus bar y is equal to r into, r means correlation coefficient into standard deviation of y by standard deviation of x into x minus bar x. This is the formula, and everyone they have to write this formula and everyone they have to keep this formula in their mind. Unless otherwise you won't write this formula, okay, you cannot be in a position to find out the values of the dependent variable, that is YC values, computed values. You cannot. So compulsory, you have to write this formula. Okay, if it is y on x or x on y, compulsory the formulas you have to write. And if you take y on x, okay, y on x, okay, you will come across the y values. And if you take x on y, you will come across only x values. Okay, that's why y minus bar y is equal to correlation coefficient into standard deviation of y by standard deviation of x into x minus bar x. This is the formula that you have to do. Now coming to correlation coefficient into standard deviation of y by standard deviation of x, we'll call that thing as, or it is represented by byx, and this is known as regression coefficient, and this is also termed as b2. Some people they'll write that as b2, and some people they'll write byx, sorry, not bxy, byx. So this thing you have to take into account when you're taking the arithmetic mean. You'll come across the covariance and you will do that. That is sigma xy by sigma x square. Like that you'll come across. But here, when you are going for the assumed mean, deviations taken from assumed mean. The formula to calculate the regression coefficient is correlation coefficient into standard deviation of y by standard deviation of x is equal to sigma dx dy minus sigma dx into sigma dy by n all by sigma dx square minus sigma dx square by n. Here the square will be for dx values only, not for n. Okay, and when you go for this, whether you go for the regression equation of y on x or x on y, the numerator will be one and the same, but the denominator will change. Mind it, the denominator only it will change, but the numerator will be one and the same. Okay. Now regression equation of x on y. Here y is independent and x is dependent. And what is the formula for that? X minus bar x is equal to correlation coefficient into standard deviation of x by standard deviation of y into y minus bar y. This is the formula. This is the formula that we will come across. So, correlation coefficient into standard deviation of x by standard deviation of y. We'll call that thing as regression coefficient. Okay, regression coefficient of x on y. When it is also represented by b1 or bxy. b1 or bxy, anything you can. So regression coefficient, that is coefficient of correlation into standard deviation of x by standard deviation of y is equal to sigma dx dy minus sigma dx into sigma dy by n all by sigma dy square minus sigma dy square by n. This is the formula to find out the regression coefficient. So first of all, you have to write the equation, formula for the regression analysis. Then after that, you have to write the formula for regression coefficient. So that's why I had given you these two formulas, and everyone they have to keep that in their memory. Don't be of that opinion that, okay, we can write only one formula. Compulsory, you have to write these two formulas first. Okay, y minus bar y is equal to r into standard deviation of y by standard deviation of x into x minus bar x. That formula. Similarly, x minus bar x is equal to r into standard deviation of x by standard deviation of y into y minus bar y. That formula. These two formulas you have to write first. Then only you have to think about the formula for regression coefficients, how to calculate. When you are taking arithmetic mean, you will come across sigma xy by sigma x square, okay, or sigma xy by sigma y square. That is the formula that you will come across to find out this regression coefficients. But when you are going for assumed mean, this big formula you have to compulsory write, and you have to solve that. Okay, so these two formulas here also, in one equation you will come across two formulas. Compulsory you have to mind it. Okay, you may think that why this man, okay, without having any brain, why he is telling 2 times 3 times like that? It is not of my brain, please. It is not of my brain. Okay, for you to understand and for you to keep that in your memory, I'm repeating that. Okay, yes, I'll agree that I'm not having any brain. Okay, I'm not having any brain, but thing is, I want to tell you and I want to make you to understand and keep that in your memory when you are going for regression analysis. Okay, now the next thing is, when you go for this correlation table, okay, you have to follow the same formula, but when you go for the regression coefficients, okay, correlation table. So coefficient of correlation into standard deviation of x by standard deviation of y is equal to, okay, sigma f dx dy Yeah, we will come across frequency. We have to take into account the frequency also. Sigma f dx dy minus f dx into f dy by n whole by sigma dy square minus sigma dy f dy square by n. This formula you have to take into account. And into, you have to take into account one more thing, into ix by iy. What is this ix and iy? Class interval of x variable and class interval of y variable. These two things you have to take into account when you are going from correlation table. And another thing is, okay, this is about dxy. I told you byx is equal to, okay, same, byx is equal to correlation coefficient into standard deviation of y by standard deviation of x is equal to, okay, byx or b2. This thing, how you write sigma of dx dy minus sigma of dx into sigma of dy by n whole by sigma of dx square minus sigma of dx square by n. These things, they are common. Only the numerator won't change, but the denominator will change. In the place of x, you have to take into account y, and in the place of y, you have to take into account the x. So these things you have to take into account. And after this, we are going for method of least squares. When you go for method of least squares, compulsory you have to follow two equations, and these two equations we'll call them as normal equations. And once if you solve the normal equations, you'll come to know about the values of the parameters a and b. So what is the formulas that we come across for normal equation? That is, what are normal equations? Sigma y is equal to, okay, n into a plus d into sigma x. That is the formula, normal equation, first formula. The second one is sigma xy is equal to a into sigma x plus b into sigma x square. Okay, that is the formula. Okay, normal equations. And first of all, you have to solve these normal equations, and after solving these normal equations, you will come across the value of one parameter, and that value we have to substitute in the first equation or second equation. It depends upon you. Okay, you can keep this in either first equation or second equation. So when you substitute the value in that equation, automatically you are going to get the value of the second parameter. So with that, the method of least squares will be completed, and you are going to get the trend values. And graphically, you have to take the trend values and you have to extend that values. Okay, when you are taking graph, compulsory, first of all, you have to plot the original data given to you. On x-axis, you have to take the number of years, that is the values, and y-axis you have to take. So there you have to take into account the original data as it is. We have to plot the original data. Then after that, you have to go for trend values. So thereby you will come to know about the trend, how it is changing. You can be in a position to estimate. The values when you are going to think about predictions or estimates for coming periods. So this thing, you must be very careful. Okay, so this is the ending for regression analysis. And those people who want to take into account, you can ring up to my cell number. My cell number is 9849238902. Okay, for problematic portion, whatever it may be, when you require, please ring up to this number, and whatever it may be, the problems that you require, okay, I'm going to give you. I know that there are so many people who can take this, but in my own way, in my style, I'm not comparing and I'm not, okay, taking others. I'm telling about myself. I know, previously I told you I don't have any mind at all. I don't have brain, but thing is, in my own style, in my own way, I am telling. And those people who can take, they can take, and those people, okay, they won't give much importance. They'll just laugh at me. Okay, fine, let them laugh. I don't mind. But the thing is, I'm going to tell in my own way, and whatever it may be, the problematic portion, if you want, I can assist and I can help to my level best. To my level best. I'm not a genius person. Okay, thank you. And in the next class, we are going for the partnership admission. Okay, so I'm stopping here, and tomorrow we are going to continue.